Hello, back again to this Golang Microservices full course, and in this video I want to share about outbox pattern. And before we talk about outbox patterns, I want to share to you about what is the problem inside monolith and then microservices. So first we have data consistency, which is in the monolith is easy because 1 dB, one transaction will be atomic. Acid is atomicity, acid is no acid in software is atomicity and consistency, isolation, and durability. If we are working on the monolith, this is very easy because we only have 1 dB and we can commit or roll back if anything wrong. We can roll back if anything works, we can commit. But in the microservices it's very hard because we have separate dB, we need a saga, which is the last time that we have already talked about saga compensation and saga pattern and saga compensation. So and then we need an outbox pattern, which is we want to learn and implement in this video. And then after that, the second is network call. So for the monolith, function call is microseconds, and then for the microservice is gRPC or HTTP, which is millisecond, but can be down sometimes. One of the service can be down, and it's will breaking, right? That's why we need a saga, and then we need an outbox. And then for the deployment, we only one binary, and then if we restart all of the deployment in the monolith. But for microservices can be deployed per service, but for the CI/CD is very complex to set up. And then after that, communication for each service is for the monolith, it's only execution code in the same process, such as wallet debit, wallet credit, and ledger record. Something like that. But in the microservice, it's need a gRPC or RabbitMQ, need a circuit breaker, need a retry mechanism, need a DL key, and this is very hard if we are new to the software development. And then after that, for the debugging, we can one call stack, so it's easy to trace. But for the microservice, because the request is spread across the services, so we need a distributed tracing. What is distributed tracing? Distributed tracing is observability technique to monitoring and tracking the request, because it will travel across the services, database, and network, right, in the microservice architecture. So we need this. So we need something like trace ID to know. To correlation ID also can use for this. If we search what is used about correlation ID in the distributed tracing, so it's synonym as a trace ID, and this is a unique identifier that this is from the start of the request, and when they are across the surfaces, this still need to be forwarded. So we can see the log for that ID, trace ID or correlation ID. This is good if we have EL key stack for the logging and the monitoring, so the logging tracing will be much easier because we know what is the ID that we have, correlation ID, right? And for this one is injected in the X request ID maybe, and the benefit of using is debugging and end-to-end visibility and system context. So yeah, then after that, how to set up the dev. For the monolith we just go run main.go, but for the microservice we need to go run main.go all of the service. If we have 5 service, then we up 5 service, so we use Docker Compose to make it easier to up to go run. And then instead of open the 5 terminal to run the main.go, yeah, in every service. Then partial failure is in the monoliths, either is all down or all up. So if the system down, the monolith will cannot accept anything. But in the microservices, if service A up, B down, it's can be happen, or C timeout, it also can be happen, so the logic will be crash. And this is the trade-off. If you are move the complexity from code to the network or infrastructure, so either you choose complex in the code or you choose complex in the infrastructure, it's up to you. But in the monolith, the big tangled complexity is in the code, but in the microservices is complexity in the network, communication, consistency. That is the problem that we will face in the microservices project, yeah. So if you see here in the monolith, if we are db wallet service db, we only call the function like wallet service db, so this will be one db transaction. But in the microservice, update wallet balance db, it can be wallet client update wallet balance, and then we need to add circuit breaker, we need to add retry, we need to add compensation. For Saga, we need to add outbox pattern because no distributed transaction, and we need to DL key if all of the function is broken or fail. So the outbox patterns we will implement in this episode isn't because this is not a feature, this is the price that we need to pay because choosing microservices. In the monolith we don't have this problem, but when microservices is worth it to try first. If you want to have a more microservice, that's worth it to do if you have a big team like a 5 team 20 plus dev. So every team deploy every service, deploy it's their service. So like one team is 20 dev or one team is 4 dev, so we have a 5 different team, one team working on the different service. It's worth it to work with the microservice. And then after that, if it's not worth, if we have a small team like 1 or 5 dev, and then after that the pros is if worth it for the microservices, you want to scale per feature. Like a wallet service need 100 instance, but ledger only need 5 instance, and need an isolation if service wallet down, the out service will not go down as well. And then tech stack is different, like service 1 is Golang, service 2 is service 2 is Python, such as like maybe wallet is Golang, and then Python is for out service or something, and then Python is for out service or notification service, and for the JavaScript can be notification service. And yeah, if you want a tech stack, different tech stack, you can use some microservice. And that's not worth use microservices. You have a small team, and then the traffic is still low, and then you don't need a scale per service, and the team is not familiar with distributed system. So yeah, the rules is first a monolith, and then we can extract to service only if we need that. So we think, yeah, the best thing if you want to start with monolith, I can recommend you using monolith modular, which is the module is separated but only one deploy. So if anything in the future we want to scale, we can extract the module to the service. And this is what you want to try, right? So I think here I want to share about the monolith function. First is transfer, which is wallet debit, credit, and record for the ledger. So this is all in the monolith we'll do with a database transaction. So first is start, then after that is commit or rollback, right? And then after that, in the microservice, we need to update the balance, we need to saga, we need to, yeah, that's what we are doing last time, right? Try compensation, outbox pattern, and circuit breaker, and then the L key, right? So this is we talk about right now, and I think I have done for the theory. And like I said, I want to work on the outbox patterns for distributed transaction. So outbox pattern is a solution for the distributed transaction in microservices architecture. So the core is to ensure the data is consistent without losing any message here. So this is guaranteed message delivery. So if a service updating the database and want to publish event to the message brokers such as RabbitMQ or Kafka, these two operation is not guaranteed to be atomic, because this is asking a different system like a DB and network broker. And this outbox pattern is want to fill the gap. So we want to write an event to the local table in the database. So the other worker will send the event from the table to the message broker. So when we need an outbox pattern, so if the transaction service is processing the transfer and status update to the success, we want to publish the event transfer completed to the RabbitMQ, so the notification service can send to the email asynchronously. What is the problem? What happen if the if the publish to RabbitMQ is fail after the database transaction commit the status to the success, because the money was deducted but the email has never sent. So this is the bad scenario if this happen. First, DB commit is success but publish fail, which is update transaction set status is success but publish RabbitMQ is fail because the broken down, money is deducted but notif email is never sent. User will complain. And then the scenario 2, publish success but DB fail. Update transaction success, this is the fail one, DB error maybe, and publish RabbitMQ is success, so email has sent transfer successful but transaction fail, so user will confuse why my transaction is success but my money never come in. This network call cannot be including in the database transaction. So this is the gap. So how the outbox patterns work. So first, db local transaction is begin, and then save update transaction status in the table transaction, and then save event in the table outbox events. So after that, db local transaction will be commit 100% atomic. This one is because one db connection, if one transaction is fail, the both will be rollback. So after that, the worker, the background process not in the request flow, will get from the outbox events and then publish to RabbitMQ and then update the status and send the email maybe, yeah. And then if the broker down for 10-minute event still in the outbox events, so this is guaranteed delivery, because even the broker is down, the data still in the database and can be doing again, redo again for the transaction notification, sorry. Okay, so I think we can start. First, I want to create new database migration. Here I think I want to try to migrate one, this one. Okay, this one I cd to the microservice and transaction service, right? Yeah, in the transaction service I do here migrate at the create outbox table. So here we get a new file inside this one. I want to copy drop table is if exists, and then I add the outbox table if don't exist here, and then I create the model inside the internal transaction model. What is this? Outbox.go outbox event id, event type, payload status, and attempts. Then after that, inside the repository I add another function which is create tx, update status tx under here, and then create outbox tx here. So we need to add the function here after create, yeah. I think here the difference is this is tx SQL tx, but this is RDBX context, so that is the difference. And I want to add this one where I can add here, should be fine. Yep, and it should be good. Now the service.go, I need to go to the line 110, service.go, service test first. I need to add SQL mock here because we had an error here, SQL mocks, and this new db test here, and after 18, yeah, 18 is here. Okay, SQL db, and then after that outbox event I add inside the here mocks tx repo. Okay, I delete. Then the create tx here, and update status tx, date status tx here, then create outbox tx and get outbox events. Wait, in where is this 112 here? Okay, and also here inside the new transaction service, this is nil. I need to create this one, change to this, and then outbox inside 221 221 here. Yeah, I think after save, yeah, save tx nil, yeah, this one. So outbox a single pending transfer complete event must be recorded. Okay, then in the transaction service again inside 250 here. Okay, new test pending only, and then no outbox. This should be after tx, yeah, this one, and after that this one, 313 here, and set 379 is where here, but we have an error because we should add this one. Where is my terminal? Go get this one, Datadog. Okay, should be not error now. Yeah, good. Then after that, Datadog. Okay, so the service, I think I add again here 110. Where is 110? 110 is here. I think create record. We do this in short transaction to release database log quickly. Inside here we copy. Here is tx repo create, yeah, tx repo create. I delete, yeah. This error is inside 121, so yeah. Okay, only until error. Okay, terminal and executed. This one is error. Wait, I need to defer rollback here until 5. Where is 5? This is 1 2 3. This is, wait, this is 149. Should be here, I think. Yeah. Wait, what happened is this transaction deployed function transaction is here. What happened with this one? Let me check. This is inside idempotency key and tx repo create. This one, right? Transfer. We do this in spirit. We add first is init until here. I wanted to copy. Where is this? We change the tx repo create here to this, and execute gRPC transfer chain is not here, but we have the function. After that we add the defer rollback. This should be no error, but this is different. The bit amount, I think correct amount dot neck. Thing here, right amount dot neck. I see. Okay, so this is new function here. Okay, this is the new function. I want to copy this one first, the X record here as this one, and this is the new func inside here. Okay, like this. Okay, and we have an error, which is this one: deduct sender balance wallet to change to the as wallet breaker. Okay, I delete this one like this, and then inside the here return nil custom error secret breaker is open. Here is copy status unavailable, this one also copy. Here violated transaction, this one receiver user ID. Okay, and then inside the X repo update status is remove, yeah, this one remove. Wait, I need to check what is the remove one. This one remove failed. Okay, this one also remove, yeah, inside this failed one. Okay, this one should be removed, and update status, the X update status compensation failed also remove. Here set inside 2 3 1, yeah, and then I copy here to here, then amounts to string. Now we only have amount, yep, and then after that, what is the, yeah, delete the 24524, this one 244, we compensation failed is delete, right, and compensation failed, and then we return compensation failed, manual compensation here, required intervention required, and the X repo also we need to remove. Here also return, we change the return wallet is unavailable, and then this one also, and then circuit receive user ID and amount, then this one as well. We check again tx repost update status, tx update status inside here also remove, I think compensation logger critical, this one should be removed. And HTTP status internal server error, I think we should change, yeah, I think this is receiver user ID, I think, yep, I want to follow first here, return nil, no, I think the return is just deleting the nil one, I think, yeah, return this one, but we also delete the repo here, sorry, the tx repo, and here amounts is also need to be changed. Then we have what, receiver user ID, and here amount, what we have again, the X repo compensation update status. If we see the X repo, the X, wait, set executed gRPC transfer chain. Yeah, we have this one. This is from transfer. No problem. This transfer, this one. I just delete the name, then months, and then delete, and then amount, then here, then remove, and then remove. Should check. Okay, amount. Here is ID, then here month, we have tx again, delete again, nil also, remove, and the tx record status. Finally here we need to what happened here, we need to return nil. Okay, we need to return nil, but we have some error again. I think we still have an error. Wait, where is the error? Receiver user ID, receiver user ID. Do we have an error here? Where an error? I think no. First is the X repo, insert the top up, insert transfer, and insert transfer. Okay, I think that's should be good. We want to open the terminal. What is the problem? Should be go mod tidy. We do the make tidy first. We do the make cd first, make tidy, and we stop the container. We do the docker compose this build, wait, sorry, make build linux and docker compose this build d. Then I'll pause the video. Okay, as I already started, I want to migrate, so I do here, which is transaction service, and here then Golang transaction. I want to try up. Okay, create outbox pattern here, and we can test. Wait a second, I want to verify inside our database, which is inside Golang transactions. I think outbox event, yeah, already here. I want to open the postman. Outbox pattern. When we log in, I think first we need to log in. Okay, login. My wallet, let me check. Okay, my wallet is okay. I think I want to send 5,000, sorry. Transaction transfer to Fern again, and 7, yeah, I think. Okay, 15 lah, to make it different. Okay, here is the transaction. Let me check in the outbox pattern. The status is pending, and we don't have an attempt yet, and transfer completed. That should be good. Test transaction 7 is success. Yeah, okay. This one is working fine, and I want to check the wallet again of current user. Okay, this should be good, and I want to check the ledger mutation, yeah, reconcile, true, still true. Transaction history, data meta. Okay, data the last transaction is test transfer 77007 and then success. Okay, I think that's all for current video and for this video. I hope you enjoy, and I think you can try to search outbox pattern in the Google. What is that and what's that mean? Yeah, something like that. Outbox pattern in Google is what? Let me check. Reliable messaging is this. So outbox table, yeah, we have outbox table. This is so handler using some transaction acid using entity and outbox, and then processor will do. So I think this is the first thing that we are doing, right? Saving order service to order table and outbox table. We have a transaction service which is to the transaction table and then outbox table, yeah. Then later we can try to make the outbox customer. Okay, I hope we can do that. Then thank you, see you in the next video.